Hi, my name is Asmaa Ahmed and I'm here to tell you about my project, The Hot and Cold of It. This project is about magnets. Magnets play a huge role in life and are a type of material or object that produces a magnetic field. This magnetic field is invisible, but it's responsible for the most notable property of a magnet, a force that pulls on other ferromagnetic materials such as iron and attracts or repels other magnets. The main question about what I am testing out is, does temperature affect the strength of a magnet? The purpose of this science experiment is to test out if different temperatures affect the strength of a magnet. The reason why I want to test this out is because magnets are everywhere. Magnets are used to make the seals of refrigerators and freezers. They power speakers and stereos, earphones, and televisions. Magnets are used to store data in computers and are important in scanning machines such as the MRI, which stands for magnetic resonance imaging, which doctors use to look inside people's bodies. My hypothesis is that the increasing of high temperatures will weaken the magnet's strength, because when magnets are exposed to heat, they experience a reduction in its magnetic fields. As for the particles within the magnets are moving really fast. The decrease of the temperature increases the strength of the magnetic field. When a magnet is exposed to low temperatures, its magnetic property enhances and its strength increases. That's because the atoms are compromised and the magnet vibrates more slowly when it's cold. The result is a better alignment of the atom that generates the magnetic field, boosting its strength. This can result in the loss of magnetic properties. In other words, heat can completely ruin a magnet. The materials required to conduct this project are 5 magnets, 200 M4 steel washers, 1 flat tray, 1 hot tray, 1 infrared thermometer, 1 refrigerator, and 1 pair of gloves. The independent variable is the temperature of the magnets, which is -0 degrees Celsius, 25 degrees Celsius, 50 degrees Celsius, 75 degrees Celsius, and 100 degrees Celsius. The dependent variable is the number of steel washers picked up by a magnet. The constant variable are the size of the magnet and the weight of the steel washer. To start this experiment, I took 5 magnets and put them in the freezer overnight in order to stabilize them at 0 degrees Celsius. The next day, I took 200 steel washers and I spread them over a flat tray. The 5 magnets are removed from the freezer and their temperatures are measured using the infrared thermometer. I had to be sure to set the thermometer at surface temperature rather than body temperature. And I wore gloves and grabbed the magnet and placed it over the washer on the tray to pick up as many washers as possible and recorded the data right after. Then I took the same 5 magnets and placed them on a hot plate until the temperature of 25 degrees Celsius was reached. The same procedure was repeated using the same magnets, and the number of steel washers picked up was recorded. These 2 procedures were repeated by bringing the temperature of the magnet to 50 degrees Celsius, 75 degrees Celsius, and 100 degrees Celsius, then placing them on a hot plate. I made sure to record the data. Based on my results from the bar graph, it states that my hypothesis was supported. When magnets are in different temperatures, their magnetic fields vary. Magnets either become weak or very strong when in different temperatures. In my bar graph, that shows as the temperatures decreased, the number of washers picked up by the magnets increased. Overall, this whole science experiment shows that a magnet's strength changes when in either hot or cold environments. My hypothesis was supported, and this experiment helped answer my question. Does different temperatures affect the strength of a magnet, and help me understand more of how a magnet works?